Welcome to the live session for SLC exam 2022. Based on many students' request, we'll be solving numerical on electricity. Definitely you can expect 2 or 3 mark question for SLC exam 2022. Dear students, do watch the complete live session and make a note of all the things what we discuss here now, and do understand the concept. The first thing, to solve numerical on any unit, first you should list down the formulas in the unit. Now what we'll do, take a notebook. Now we'll try to list down the important formulas in this unit. Students, from this unit, the first formula, the important formula what you can is I equals Q by T. Current I equals Q by T. The next formula, potential difference V equals work done to move a charge Q. V equals W by Q. Current I equals Q by T, V equals W by Q. Now the very important relation, definitely based on this formula, you can expect the formula, that is Ohm's law, which says that what? V equals I into R. Students, do repeat with me. Based on Ohm's law, definitely can expect question. V equals what? I into R. Potential difference V equals current I into R. Here we can express I as what? V by R. Just cross multiply. Or we can express R equals what? V by I. Students, make a note of all these formulas. Ohm's law states that what? V equals I into R. To find out I, when V and R is given, that is I equals V by R. R equals V by I. Next important relation in terms of resistance and resistivity, that is R equals rho L by A. R equals rho L by A. Resistance R equals, rho means resistivity, length of the conductor divided by area of cross section. When the resistance are connected in series, the effective resistance Rs equals R1 plus R2 plus R3. When the resistance are connected in series, that is R1, R2, that is end-to-end connection, the effective resistance Rs equals R1 plus R2 plus R3. In the same way, when the resistors are connected in parallel, that is R1, R2, R3. When the resistors are connected in parallel, the effective resistance between the endpoints, that is 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. Students, it is very important to know all the formulas. Do make a note of all the formulas. Definitely it will be useful to answer 1 mark question and also to solve the problem. And also knowing SI unit of all this way is very important. Now students, we have Joule's law of heating. It states that what? H equals I square RT. Joule's law states that what? H equals I square RT. Based on this, you can expect 2 mark question. H equals I square RT. Next, very important formulas. We have seen 3-mark problem on finding the power. That is, power equals what? Power P equals V into I. Make a note. Power P equals V into I. We can express power V as power P equals I square R. Replace V by IR, we get P equals I square R, and also we can express P equals V square divided by R. These are the ways we can express the power. Students, first formula, I equals Q by T, V equals W by Q, Ohm's law, V equals I into R. We can express I equals what? V divided by R, and also R equals V divided by I. And resistivity relation between resistivity and resistance, R equals rho L by A. When the resistors are connected in series, the effective resistance Rs equals R1 plus R2 plus R3. When it is connected in parallel, 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. H equals I square RT. That is, heat generated in the conductor is directly proportional to square of the current and also resistance and time. This is what Joule's law. And power P equals V into I, or I square R, or V square by R. Students, if you solve the problem, you'll definitely understand all this. Make a note of all these formulas. Students, for this exam, the questions will be asked from the textbook only. So do solve all the questions which are there in the textbook. Definitely that will help you to score 2 or 3 marks in the examination. The problems will be very simple, so don't think that the problems will be difficult. The questions will be difficult. The only thing, practice all the exercise and textbook questions. Now we'll start solving the problems. Dear students, moving to the first question. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohms? Student, first always write down the given data. First always write down the given data. What is given here? It is given the voltage V equals what? 220 volts, and the resistance R equals what? 1200 ohms. What we need to find out? We need to find out current. So current I equals question mark. See here, what is the relationship involving voltage, resistance and current? It is Ohm's law, right? So using Ohm's law, what Ohm's law states that V equals I into R. Students, at least you should apply the formula in the exams. At least for applying the formula, writing the formula, you'll get the marks. So now what we need to find out? I. So keep I and cross multiply R. So I equals V divided by R. What is the voltage? Voltage is 220. Resistance is what? 1200. Now I equals 0 and 0 will cancel out. What we get is now 22 divided by 120. Now 2 11s are 2 60s. What we get is 11 by 60. Now if we divide 11 by 60, we get around 0.18 ampere. Therefore the current drawn by electric bulb is what? 0.18 ampere. Students, writing the units are very important. So it is 0.18 amperes. Now the sub question for the same question: how much the current drawn by electric heater coil is 2 ampere from 220 volt source. Calculate its resistance, and if it draws 1 ampere, find the potential difference of the circuit. Students, the current drawn by electric heater coil is 2 ampere from 220 volt source. So given what? Given I equals 2 amperes, voltage V equals 220 volts. What we need to find out? We need to find out the resistance. R equals question mark. Again, by using Ohm's law, V equals what? I into R. Now R equals what? V by I. V equals what? V equals 220. I is 2. Now R equals 220 by 2 is 110 ohms. So the resistance of the electric heater is 110 ohms. Now if it draws 1 ampere current, find the potential difference of the circuit. Now the current value is changed to what? It is changed to now 1 ampere. Resistance will be same, that is 110 ohms. We need to find out the potential difference V. Now again, by using the same relation, V equals I into R. Now V equals, what is I? 1 ampere into resistance is 110. We get V equals 110 volts. Therefore the potential difference is what? 110 volts. Students, hopefully, first, what is the first step? Write down the given data, then apply the formula. We have listed down the many formulas. Based on those for many of the problems, you will be using what? Ohm's law. Apply Ohm's law, find out the unknown value. This kind of question is very important. If initially 2 ampere of current is drawn, next condition, what is the voltage if same circuit draws 1 ampere current. This kind of question is very important for the exam. Students, moving to next question, and very important question. The potential difference between the terminals of an electric heater is 60 volts. That is given voltage V equals 60 volts. It draws a current of 4 ampere, that is I equals 4 amperes. What will the current, what current will the heater draw if the potential difference is increased to what? 120 volts. How much current will be drawn by the heater if it is the voltage is increased to 120 volts? Now what is the unknown quantity we need to find out? That is R equals question mark. But again, by using Ohm's law, V equals what? I into R. Now R equals what? V divided by I. Now R equals, what is V? 60 divided by I is 4. Now we get resistance R equals 15 ohm. 60 divided by 4 is 15 Therefore resistance R equals 15 ohms. Now students, the second condition what you can check here is what is the current drawn by the heater if the potential difference is increased what 120. Now for case 2 V equals what 120 volts, resistance will be same, R equals 15 ohm. We need to find out current I. Again by using Ohm's law, V equals what I R. I equals V divided by R. What is V? 120 divided by resistance is 15. The resistance will remain same. You can change the value of potential difference or the current. Therefore 120 divided by 15 is 8. Therefore the current drawn by the heater will be 8 ampere if the potential difference is what increased to 120 volts. What is the first condition? The first condition was voltage was 60 volts, current is 4 ampere. We need to find out the resistance. After finding the resistance, R equals 15 ohm. Same value should be substituted toward the second condition because the resistance remains same. Now what was the voltage value? It was increased to 120 volts from 60 volts to 120 volts. The current, how much the current will be drawn by the heater? It will be 8 amperes. Students, moving to next question. 100 joules of heat is produced each second. 100 joules of heat is produced each second in a 4 ohm resistance. Now I'll note down the given data. That is heat H equals what 100 joules and time is what each second, that is 1 second. Time is what 1 second. R equals what 4 ohms. 4 ohms. Find the potential difference across the resistor. To find the potential difference, we should know what value of current as well as resistance, right? What is the current value? The current value is unknown here. So what is the relationship connecting heat, time, resistance and current? That is using Joule's law of it. That is H equals I square T. Now I square equals what? H by R T. Now what I equals what? Square root of H into RT. H divided by RT. What is the heat produced? The heat produced is what? 100 joules divided by resistance is 4. Time is 1. 4 ones are 425. So square root of 25. We get current I equals 5 ampere. Now we got current I equals 5 ampere. Now use the resistance value and the current value to find out the potential difference. Now V equals what? I into R. Potential difference V equals I is what 5. The resistance value is 4. Therefore V equals what 5 into 4 is 20 volts. Therefore the potential difference across the resistor is 20 volts. Moving to next question. An electric bulb is connected to a 220 volt generator. The current is 0.50 ampere. What is the power of the bulb? So power V equals what? V into I. Power V equals what? V into I. This is a simple 1 mark problem. Power V equals what is the voltage? It is 220. Current is 0.5. That is P 220 into 0.5 is 110 watts. Therefore the power of the bulb is 110 watts. Students, moving to next question. Very important question. We have seen this kind of question asked for 3 marks in the preparative paper and also in the model paper. An electric refrigerator rated 500 watts, that is given power equals 500 watts, operates what? 8 hours a day. Per day it works for 8 hours a day. 8 Time is what? 8 hours per day. What is the cost of energy to operate it for 30 days? Number of days is 30 days. What is the cost of the energy to operate it for what? 30 days at rupees 5 per 1 kilowatt hour. Students, the first step what you should do is you should calculate the total energy. The total energy consumed by the refrigerator for 30 days. Per day it is 500 into 8, right? Per hour it is 500. For 8 hours it is 500 into 8. For how many days? It is for 30 days. The total energy will be 500 into 8 into 4. How many days? It is 30 days. So what I get? Just multiply 500 into 8 into 30. We get 1,20,000. 1,20,000 watts hour. This is the amount of energy used for 30 days. I'll convert it into kilowatt hour, that is divided by 1000, that is to convert into kilowatt hour divided by 1000, 3 zeros cancels. What we get is 120 kilowatt hour. What is the total energy consumed by the refrigerator for 30 days? It is 120 kilowatt hour. What is the rate for per kilowatt hour? It is rupees 5. Now just what you should do, the cost of energy will be 120 into what? Per watt, per kilowatt hour it is 5. For 120 kilowatt hour it is 120 into 5. We get, just multiply 120 into 5. It will be 600. The cost of energy to operate for 30 days is what? 600. Students, there is a similar question in the textbook. You can solve, and also in page number 114 you have an in-text question. An electric motor takes 5 ampere from a 220 volt line. Determine the power of the motor. That is very simple. P equals V into I, and the energy consumed in 2 hours. That is very simple problem. That kind of question, do solve that question and comment your answer, or send me the answer in the Telegram group. Page number 114 in part 1 book. That is question number 2 in text question. Dear students, the questions will be very simple, and also we have a problem in page 112, question number 3. Do solve that question and comment your answer. That is page number, you have understood the, at least you have understood how to solve the problem. Page number 112, question number 3. In the same way, page number 114, question number 2. That is in text question. Students, try to solve all the textbook problem first and understand it. Definitely just the values will be changed, the questions concepts will be same. And also there is a very important problem in page number 106. Page number 106 question, example 12.7. That is very simple, students. When the resistance are connected in series, the effective resistance is what? Just add the resistors. Well, if it is 10 ohm, it is 5 ohm. The effective resistance will be 10 plus 5, which will be equal to 15 ohm. The effective resistance RS equals 15 ohm. Students, I hope this is enough for today's session. Students, try to solve. I have shared science workbook. It contains 10 problems. I have solved around 4 to 5 problems. By understanding all these problems, try to solve other 5 questions. Students, you know the formulas now. List down the formulas. You should understand the formulas and you should know the formulas to solve the problems. And also try to solve as many example questions which are there in the textbook. First, try to concentrate the problems which are in the textbook. Repeatedly I am saying, first try to concentrate the questions which are there in the textbook. So thank you for the attending the session, students. Hopefully at least this has given you clarity about how to start the problem. It is very simple. For many of the question we'll be using Ohm's law, that is V equals I into R, and also one problem we have used Joule's law of heating, H equals I square RT, and mostly you can expect 3-mark question based on what? Calculating power. So students, thank you for watching the live session or attending the live session. Do subscribe the channel. Tomorrow we'll solve numericals on reflection and refraction unit. That is very important chapter. Definitely you will expect 3-mark problem.